All right, we are in section 2.5 where we're going to um, use reason uh, by using the properties from algebra. So first things first, we're going to take a look at some properties that are going to help us solve different algebraic equations where we use them all the time. We just don't ever call them by name um, all the time. So first things first, we're going to let A, B, and C be real numbers, whether they're rational, irrational, integers, whole numbers, whatever it may be. They're going to fall into that real number umbrella. So the addition property of equality basically states that if A equals B, then what we can do is we could add on any value C to either one of the values and still be equal. So I could take A plus C and equal it to B plus C, and you would still get the same value. Same thing goes for subtraction. Again, if A equals B, then we could subtract both A and B by C and still get the same answer. Okay. Uh, Again, with multiplication, yeah, if we took and multiplied A times C, it would still equal B times C because A and B still equal each other. Division property states that we can do the same thing with division and say A divided by C will equal B divided by C as long as C does not equal 0. And then substitution property says that if A equals B, we can substitute A in for B for either equation or expression. So we can put A can be substituted for B in any equation or expression. So for the most part, these are the properties that we're going to use today and um, show how we can kind of write a formal proof using algebra. So looking at this first example here, it says solve 2x plus 3 equals 9 minus x, and it says write a reason for each step. So for this particular one, they gave you the reasons. All right, this is a 2 column. We got, you know, this is to set up our proof on the left-hand side, and then our reasoning is on the right-hand side. So what we can then say is, first off, anytime that we're going to write a formal proof, we are going to start off with what is given to us. Okay, and so what is given to us is this equation. The 2x plus 3 equals 9 minus x, that is given. So that's why we can put given here as our reasoning. The next thing we can say here is, right here it has 2x plus something plus 3 equals 9 minus x plus something, and they're telling us it's the addition property of equality. So in most instances, you're trying to get variables on one side, numbers on the other. In this case, in order to get rid of a variable, I can get rid of the right variable by adding x. So since I do it to the right-hand side, I must do it to the left-hand side. So adding x to both sides actually cancels them out, which then now allows us to cancel this and then combine here, which then puts us at 3x plus 3 equals 9. So that's just from simplifying or combining like terms. Then from here, the next step says it's the subtraction property of inequality. So that means we're subtracting something. So that means I'm subtracting 3 from both sides. So when I subtract 3 from both sides, I'm left with 3x over here, and I'm left with 6 on the right hand side. That's my reasoning. The final step just has x equals something, and it comes from the division property, so it means we're dividing something. In this case, it's 3. So I'm left with x on the left hand side, and I'm left with 2 on the right hand side. So x is 2 is my answer, and because of the division property of equality allows us to uh, make that um, make that proof. Okay. Let's look at another one. First off, we have the distributive property. Same thing goes, like letting A, B, and C be real numbers. So what they did here is they had A on the outside. On the inside, they had the sum of B plus C. All we're doing again, just multiplying A, multiplying B. That's why we can have AB plus AC. So that is another property that we're very familiar with, but we always don't put it as a reason for why we solve a particular equation. So here we got negative 4 times by the quantity of 6x plus 2, which is equal to 64. All right, just like the first example, we're going to write down what is given to us, which is the problem, and then we write it down as given. So here we have some, next step, we have some blank pieces on the left-hand side of the equal sign, and they gave us a blank for a reasoning. So we must distribute. So when we distribute, we get negative 24x minus 8, and the reasoning for that is the distributive property. Okay. Uh, and we will go about solving one of these. We are going to add both sides by 8. So when that happens, I'm left with negative 24x is equal to 72. And because we added, that means we're going to use the addition property of equality. And then the final thing we're going to do is divide both sides by the negative 24 because it told us that. And x in this case is going to equal a negative 3. Okay, so here we have ourselves kind of a story problem, but they also want us to write in a proof. It says a motorist travels 5 miles per hour slower than the speed limit S for 3.5 hours. The distance traveled d can be determined by the formula d equals 3.5 times by the quantity of s minus 5. They're asking us to solve for s. So we have two variables, but they only ask us to solve for one. So they're asking us to solve for s. So that means at the end of this problem, it's going to be s equals something. Okay, it's not going to be a singular answer because we have two variables, s and d. So here we go. First thing, write down what's given to us, which was the formula. So we got here. Um, the next step, we still have d equals something. We are going to distribute. So when we distribute, it's going to be 3.5s minus 17.5, and the reasoning for that is the distributive property. Next step from there, it's d plus something. So d plus something, it means I'm going to add 17.5 to both sides. So that means that d plus 17.5 is going to equal 3.5s. And the property that allows us to do that is the addition property of equality. And then finally, it just has now s equals, which is what we're looking for. So we're going to divide 3.5 to both sides. So now it's going to be d plus 17.5 on the top, all divided by 3.5, and that is going to equal s. And since we divided, that means we're now going to use the division property of equality. We also have some other properties of equality that can pertain to uh, length measures for line segments. We could also be dealing with angle measures and real numbers. So we use real numbers with the previous couple pages of the notes, but now we can also look into how it pertains to angle measures and um, segment lengths. So here, if we're going to talk about the reflexive property of equalities, it says for any real number A is going to equal A. And then for any segment AB will equal AB. And then for any angle A, the measurement of angle A will equal the measurement of angle B. All right, it's usually when you're dealing with geometry with these types of values, it's usually when it's uh, needed is when you have shapes that kind of overlap each other and share either common segments or they share common vertexes. So keep that in mind. Here is the symmetric property of inequality. So here they're saying that for any real number A and B, if A equals B, B equals A, you just flip them around. Same thing here. It says for any segment AB and CD, if AB equals CD, again, you just flip it around and say CD equals AB. And then for any angles A and B, the measurement of angle A will equal the measurement of angle B. Again, you flip them around and you can easily say the measurement of B will equal the measurement of A. Here, this is the transitive property of equality. So here it says for any real numbers A, B, and C, if A equals B and B equals C, then A is going to equal C. That's almost kind of like when we talked about the law of syllogism. If we say if this, then that, this is hypothesis P and hypothesis Q. We can make another hypothesis if those statements happen to be true. Same thing here goes with line segments. If AB equals CD and CD equals EF, then we can say that AB equals EF also. Angle measures, angle A will equal angle B will equal angle C. Then we can say that angle A is also the same measurement as angle C. Okay. So we look here. Uh, in these three examples, they want us to state the property of equality that each statement illustrates. So here it says GH is equal to JK, then um, JK is equal to GH. So it's that flipping of the two segments. So this is a symmetric property of equality. Next, it says if R equals S and S equals 44, then R equals 44. So this is where you can say, this turns into when you talk about values, we can go about and say, all right, this is part of that transitive property, okay? Because this is like, oh, we got A equaling B, and then this is B equaling C, so then we can say that A equals C. So that's where that comes from. And then the measurement of angle N equals the measurement of angle N, hence the same thing. This is the reflexive property. Okay. All right, so now this is a situation where we don't have any parts of the equation, any parts of the reasoning. This is now we're going to have to write out a formal proof for these two equations. So looking at the first one, we got x minus 5 is equal to 7 plus 2x. What you're going to do here is rewrite what we have. So you got x minus 5 is equal to 7 plus 2x. That is given to us. All right, from here, when you go about solving, you want to put all variables on one side, all non-variables on the other. So let's take care of that. So let's look at the variables. So if I subtract x from both sides, I am going to get now -5 is equal to 7 plus x. And because I subtracted both of them, values of x, it's the subtraction property of equality that allowed me to do that. And then from here, I can subtract 7 from both sides. So now I have -12 equals x. And because, again, I subtracted, it's the subtraction property of equality. And I found what x was, so now that's my answer, and those are my reasonings. If we look at this next example, we have 4 times by the quantity of 5 minus x, which is equal to -2x. So again, rewrite the equation, and that is given to us. So now we are going to distribute here. So 4 times 5 is 20. 4 times a negative x is minus 4x, and this equals -2x. And the reasoning is the distributive property. Next, we can now say get all variables on one side. In order to do that, I got to add 4x to both sides. So now I have 20 is equal to 2x. Because I added, it's the addition property of equality. And then finally, I'm going to divide everything by 2. So I get 10 equals x because I divided, it's the division property of equality. And we got 10 equals x. Okay. So now we are going to apply, all the different properties that we looked at in the hopes that we can show that CF, which is right here, is equal to AD, which is right there. All right. So we have to do some proofs. We have some of the information. We have to kind of add on whether it's something that was given to us, or we have to talk about what property allows us to make that statement. So right here we can say, if you look at the drawing, we have hash marks at AB and we have hash marks that are the same in EF. So I can say that AB is equal to EF because it's something that is given to us. Also, we have 2 hash marks between BC and DE. This is something that is also given to us. Okay. Um, the third step here, it says AC is equal to AB plus BC. All right. So what allows us to make that conclusion is a segment addition postulate. All right, you can add those two together. Same idea, segment addition postulate is being used with DF because it's going to be DE and EF. Using the same idea, it's the segment addition postulate. Okay, so keep moving forward. Now they're saying that we can say that DF is equal to BC plus AB, which is what we have right here. So we ask ourselves, what property is that? What we can then conclude is, since these hash marks here are the same as these hash marks here, we can say that this comes from the substitution property. of equality, which is what we talked about on the first page. If they both equal to each other, we can replace them and utilize utilize that information. And since DE is equal to BC plus AB, that also means that DF is equal to AC. And again, all you're doing was just substituting equal parts to get an equal, the same equal value. So now we have DF is equal to AC. So if I said so if I found DF is right here and AC is equal to that here, that does make sense. All right, and it's for those properties that allow us to make that conclusion. So now here it says that DF plus DC is now going to be equal to uh, AC, which is what we have up here, plus um, CD. So this is kind of like where you have, you know, A equals B, like this was A and that's B, and then we add them. So now we can say that this is just from the addition property of inequality. So we're just adding DC to both sides. They're still going to be equal. And what now we can say is DF and um, what we can say here from now is CF can be equal to AD because of the segment addition postulate. Because if you look here, we have C, hold on, DF, which is right here, and CD, which is right here. We're saying that that is the same as AC, which I'll put a different color right there, and DF, which is right there. So if those are equal, now we can make the conclusion that CF right here is equal to AD. Because see how the black and the blue. So that's how we were able to make that conclusion. And CF and AD are right there. That's what we're trying to show. And we made that proof. And that is being able to use properties from algebra. Hope this helps. Till next time.